All right, we're moving on to U4, which is to find the number of solutions to a system of equations by graphing. I have a few reminders for you. Remember when we were working in the S's and we were talking about how we knew the difference between lines that were parallel and perpendicular? I need you to remember these things. Parallel lines have exactly the same slope. Perpendicular lines have opposite reciprocal slopes. In other words, the opposite sign, and you flip the slope over. Now, how does this relate to systems of equations? If both lines have the same slope, then there's no solution, because remember, a solution or an answer is where the lines cross. And if they don't cross, then there's no solution. If the slope is not the same, there's one solution, because they have to cross somewhere. The other part you need to remember, or actually know, is if the lines have exactly the same slope and the same y-intercept, there are an infinite number of solutions. An infinite number of solutions, meaning that any point on the line, any point at all on this line, could satisfy both equations, making the system true. So let's go ahead and look at what we have here in U4. We're told graph these equations. We already know how to graph them, so let me just do that quickly. It's -4, and we're going to go down 2 and to the left 3. And then for this line, it's going to be down 4, or starting at 4, down 2, and to the right 3. Now, you probably could tell by looking at this, they're exactly the same line. So if they're exactly the same line, that means that any point on this line makes the system of equations true, so it has infinitely many solutions. So here we have x is equal to -6, so we know that is a vertical line. Let's put our line there. And x is equal to -7. Well, they're parallel to each other because they run right alongside of each other. So this has no solution. Then let's look at this one. We have, again, y is equal to -x minus 4, so let's graph -4. We know this is down 1 and to the right, because our line should be falling from left to right because of this negative here. And then x is equal to 2. Well, let's graph that. There's one solution. Notice their slope was not the same. So we have one solution. Now let's look at this one. So we've got +6, but we're going to go down 3 and to the left, to the right 1. Then we are at -6, down 3, and to the right 1. And again, these are parallel lines. Look at their slope. They're exactly the same. So we would say this has no solution. Now this one, we start at 3 for the first equation. We go up 1 and over 1. And notice the slope is the same. So hopefully, if we do this right, these lines should be parallel. Next line, we're going to graph at -1. Oops, I didn't do that right now, did I? So we're going to go up to 3, up 1, over to the right 1. Then we're going to go down to -1, and we're going to go up 1 to the right 1. And again, they're parallel. The slopes are exactly the same. So we're going to say this is no solution. All right, now notice this one is in standard form. So you can use the cover-up method to graph this, and that would be okay. So we have x plus 2y is equal to 8. And then we have x plus 2y is equal to -2. Well, we know if we cover up 2y that x is equal to 8. Therefore, our ordered pair would be 8, 0. Cover up x, and we have 2y is equal to 8. Therefore, y is equal to 4, which means our ordered pair is 0, 4. So we could graph it that way. We've got 8, 0, and then 0, 4. And then on the other one, cover up again. We've got x is equal to -2. Therefore, our ordered pair would be -2, 0. Cover up x this time. And then we've got 2y is equal to -2. Therefore, y is equal to -1. Our ordered pair would be 0, -1. So we've got, for this one, -2, 0. And then we've got 0, -1. And look at that, they're parallel. Now, if you noticed, if you wanted to change this into slope-intercept form, you could have done that as well. And you really didn't even have to finish the rest of it. You could have said x plus 2y is equal to 8. Subtract x from both sides of the equation. And we're left with 2y is equal to -x, I don't know why I wrote 8 there, plus 8. And you really could stop right there if you're already graphing it. If you're going to change it into y-intercept form to graph it, though, go ahead and divide by 2 every term, and then I have y is equal to -1/2 x plus 4. And let's see, is that our first line? 4, and we go down 1 to the right 2. Yes, that's right. And then you could change the other one as well, x plus, I'm so sorry. Now you can see that. X plus 2y is equal to -2. Subtract x from both sides of the equation. And you're left with 2y is equal to -x minus 2. The slope is exactly the same. Again, though, if you're going to use this method to go ahead and graph, you need to finish it. So y is equal to -1/2 x minus 1. And that's exactly what happened. We had a -1 intercept, and then we went down into the right 2. So on this one, because the lines are parallel, we have no solution. So when you have one that comes up like this, you can graph them just however you choose to. If you want to change this and make sure that you have them both in y-intercept form, you can. Or you can graph one in standard form and graph the other in y-intercept form. Let's go ahead and take a look at that. So you have x minus y is equal to -2. And then y is equal to -2/3 x minus 3. So I think what I want to do is I want to have these in, no, I'm going to do it both ways. So I'm going to use cover up. I'm going to cover up y, and I have x is equal to -2. That means my ordered pair would be -2, 0. Cover up x, and I have -y is equal to -2. Well, I don't want -y. So if I do this, I must remember to either multiply or divide both sides of the equation by -1, and that would give me positive y is equal to 2. Therefore, my ordered pair would be 0, 2. Now, I'm not going to change this into standard form because it's already in a good graphing form, which is what the slope-intercept form is. If I wanted to, I could go back to this one and change it into y-intercept form or slope-intercept form. So I want y alone, and I want it to be positive. So I'm going to add y to both sides of the equation. And so I've got x is equal to -2 plus y. And I want y alone, so I'm going to add 2 to both sides of the equation. And I've got y is equal to x plus 2. If it bothers you, write it the other way. As long as the signs travel with each term, you're fine. So y is equal to x plus 2. Now, notice that my y-intercept is 2. And when I did the math using the cover-up method, my y-intercept is 2. So it really doesn't matter which way you choose to use it. So I've got 2, and I'm going to go up 1 over 1 to the right. And then I've got this one, this equation, it starts at -3. It's a negative slope, so my line should be falling from left to right. So I think I'm going to go up 2, 1, 2, and to the left 3, 1, 2, 3. So as you can see, we have one solution, and we could tell that automatically from the slope. This slope right here, the slope right here is x. However, the slope here was -2/3. So it's not parallel because the slopes are not the same. It is not perpendicular because the slopes are not opposite reciprocals. Also, it is not infinite because the lines are not the same. So I hope this was helpful. We'll pick up on the next one. I'll see you then.